accepted.
All right. Come on in. There are plenty of seats in the front. Make yourself feel comfortable. This is 4A. We're going to talk about Istio. Future of Service Mesh is Sidecar-less with Istio Ambient Service Mesh. Come on in. A quick introduction about myself. My name is Len Song. I'm the head of open source at Solo.io. How many of you heard of a small company, Solo.io? Okay, a few of you. Very cool. Thank you. So I actually joined Solo about 2 years ago. Before I joined Solo, I worked about 20 years at a big company, IBM, which many of you already know. And while at IBM was a co-founder of Istio. I was one of the founding members at the Istio project when I worked at IBM. And I wrote a book, Istio Explained, while I was at IBM. IBM is also a big thing about patents and innovation. So before I leave IBM, I took a screenshot of my corporate directory, and I had 207 patents, all granted to IBM, but I'm the inventor or co-inventor. So last year I wrote a book, Istio Ambient Explained, trying to help you all understand what ambient is, what is this new innovation we have in the Istio community. All right, this is a little bit introduction about our company. It's founded by Eddie Loving, who is my boss. A couple of years ago, we're based in Cambridge, so I'm actually flying 20 plus hours to be here. It's the first time in Krakow. Really, really cool city here. And our company is very well funded. We have a lot of Istio and Envoy expertise. One thing really fun with our company is we give free workshops with the environment to help users to learn Envoy, Istio, Ambient, eBPF. So if you're interested in taking our free workshop, that's the QR code to scan to get to our workshops. So how many of you know what Service Mesh is? All right, most of you, very good. So for those of you who don't know, a service mesh is a programmable framework that allows you to observe, secure, and connect your microservices. In the keynote earlier, the gentleman, sorry, I forgot his name, but he was talking about design being really, really hard. So service mesh is an interesting design pattern. Instead of having you to code in your application to observe, secure, connect microservices, it's offload that work to the service mesh framework to do so. So you don't have to worry about within your application, which might be written in different languages. So this is a typical architecture of service mesh. Well, typically you have a control plane and a data plane, right? So on the top tier, it's the data plane where your application is dragging the sidecar. I typically think it as your luggage as you travel through the airport, right? You always drag your luggage with you. That's the function of the sidecar. It provides the essential functionality to enable your applications to connect, secure, and observe with other applications in the cloud-native world. The service mesh control plane allows you to program these sidecars so you don't have to kind of program the sidecar yourself. The service mesh control plane typically have declarative YAML configuration where you can, the operator or either the security operator or network admin operator can program the control plane, which further programs the sidecar to do whatever you need, whether it's increase the resilience of your application, traffic shifting, apply mutual TLS, apply reach back policies. That's what that sidecar does for you with the help of the control plane. So you don't have to learn the specific language of the proxy. For instance, let me give you an example. Envoy proxy is the most popular proxy used in the service mesh landscape. And just to program a couple of applications, Sidecar proxy that's Envoy based, we're looking at tens of thousands of configuration, which is not really understandable and programmable by human unless you really know Envoy really well. What we are involving with Ambient, though, is we've heard a lot of feedback from our user. They don't want to drag that luggage as a sidecar with their application. They would rather having that sidecar live outside of the application. By the way, how many of you have actually used Istio with sidecar today? All right, a few of you, very good. And how many of you, if you have a choice, would rather not have that sidecar with you? All right, a few of you too, very good. So this is exactly what Ambient service mesh is going after. Well, we kind of extracted that sidecar outside of your application. So what does that mean? That means you don't have to make any change of your application, right? Whether your application does one thing, you don't have to always drag that sidecar with you. We essentially allow that proxy to running outside of your application. And what's even interesting with Ambient is we slice the architecture into layer 4 and layer 7. So for layer 4, where we believe because the functionality is minimum, right? It's focused on mutual TLS. It's focused on layer 4 authorization policy. So we can have a per node shared proxy that's co-located with your application on that particular node. So that's kind of the architecture of layer 4 proxy with Ambient. This is also a trend in the service mesh industry because a lot of our users have been telling us, hey, having that sidecar proxy running along with my application is very hard to maintain. It's very costly. It doesn't scale independently from my application. So when I need 10 replica of my application, I had to pay 10 replica of my sidecar, which is really not ideal. So that's one of the architecture we are innovating in the community with Ambient. So let's talk a minute about Istio. Certainly, I could be a little bit biased because I've been working on Istio for a very, very long time. So it's, in my opinion, it's the most deployed industry's leading service mesh in production. So Istio was first launched in 2017. And last year, Istio was accepted in CNCF as an incubation project. We're actually working on the graduation process, so we do expect Istio to be accepted, finger crossed, by CNCF as a graduation project. Also at the same time, last year we launched Istio Ambient Service Mesh. So this was the announcement. When Ambient goes out, you can see a lot of momentum around Ambient on Twitter. Well, the key thing is we introduced a new data plane mode for Istio without sidecar. And we also published a blog where we introduced Ambient Service Mesh to the community to help user understanding. And I was one of the co-authors of the blog from Solo. All right, so let's introduce the Ambient Service Mesh. At the end, I want to talk to you about the benefits of Ambient, right? So you got it, it's a service mesh data plane without sidecar, but what's the benefit, right? The biggest benefit, in my opinion, is simplify operations. So instead of you have to tell us, or somehow inject the sidecar manually yourself, or ask us to automatically inject the sidecar for you, you no longer need to do so. So there's no change to your application. So that means as you add your application to Ambient, you don't need to restart your application, which is super, super cool. So that's the biggest benefit. The other thing around simplified operation, I would say, is because Ambient is more transparent to your application. We no longer need any of the application requirements. For example, today we have application requirements such as these ports, you can't use it in your application because guess what? The sidecar using them, so you can't really use them. We have requirements such as Kubernetes jobs. A lot of users are using jobs, and we tell them, well, because we can't control the life cycle between your application as a job to our sidecar really well, so we can't really support jobs. So these are the things where we really are targeting Ambient to support through that simplified operation. The second benefit is cost. I kind of explained this earlier just to emphasize the cost of saving, especially if we just need the Istio or service mesh for layer 4, which is mutual TLS, cryptographic identity, and layer 4 authorization policy. In that case, you would just pay for the per node proxy, and we have observed 90% cost of saving in that case through our testing and our lab. Improved performance, I put that as the last goal. This was not really the initial goal when we introduced the Ambient, but we do think it's going to improve performance, particularly in the cases when you need only layer 4 functionality. In that case, you would just have a hop through the layer 4 proxy and then to the target layer 4 proxy in that case. So we do believe that layer 4 proxy is going to be way more high performant than the Envoy based proxy, which does a lot of layer 7 processing work, typically where most of the time are spent. So this gives you a little bit more details of the Ambient architecture, where we are moving from a sidecar proxy to which is a proxy per pod architecture, to a proxy per node architecture. As you can see, you literally with this new architecture, you deploy way less proxy because there's a lot of sharing, right, on that particular node. You only have one node proxy on that particular node. And on the right side, we kind of outline different benefits through the lens of different owners. I think how many of you are kind of part of the business owner? All right, and how many of you are platform team? All right, how many of you are developers, the application team? I'd imagine majority of you, yes, right. So for you, in that case, I think for application developers, the huge benefit would be it's transparent to your application, right? There's no need to restart your application. Your application would be not break. There are the ability to scale independently of the proxy from your application. So those are the different benefits for you. With Ambient, we continue to enable the zero trust architecture, which is the most widely adopted feature of Istio. So a lot of people adopt Istio because they need mutual TLS in their corporate security team as a requirement. They need FIPS compliance. They need to go through FedRAMP certification. So in this case, we have a per node proxy, which is the layer 4 proxy on this side. I'm sorry, on my screen, it's on a different side. So we have the layer 4 proxy that handles mutual TLS, same as the sidecar mode, except the layer 4 proxy is going to manage and mint the certificates for all the pods co-located on that particular node. Ambient also enables service mesh flexibility. This is also what we talked about earlier. With this architecture of per node proxy, you literally enable you to save on the cost. save on operation. When the proxy has a new CVE, you no longer need to restart your application. And some of the performance flexibility we talked about earlier, well, the proxy can handle focus on layer 4 processing. So that means the attack surface for the layer 4 proxy is actually much reduced when compared with the sidecar, right? Because if you look at the Envoy CVEs out there, I believe 2/3 of the CVEs come related to layer 7 processing. So in that case, hackers would have a way to potentially hack your sidecars. Well, they couldn't hack the layer 4 proxy if the CVE resides in the layer 7 processing, because the layer 4 proxy doesn't do layer 7 processing. So in one sense, we do think Ambient is actually more secure with this architecture because of the reduced attack surface for the layer 4 proxy. All right, let's go to a little bit on the Zero Trust Tunnel, which is what Z-Tunnel stands for, the Zero Trust Tunnel architecture. So essentially, the Zero Trust Tunnel is the per node proxy. When we first launched Ambient in September last year, we started using, implement Z-Tunnel using Envoy proxy. But as time goes by, we find out that it's very, very complicated to implement and code the Envoy configuration for the Zero Trust Tunnel, because Envoy wasn't inherently designed to handle multi-tenancy. So we had to build a lot of internal listeners inside of Envoy. So at the end, there was 3 developers who can understand over Z-Tunnel configuration. So this year, towards the end of last year, the community decided to rewrite the Zero Trust Tunnel using Rust, which is a popular high-performance language for proxy out there. So we decided to using Zero Trust Tunnel to written in Rust to build the HTTPS connect tunnel between the source and target destinations. So as a request coming, you will say, let's say if C1 calls server 1, the request would be captured by the Zero Trust Tunnel through either IP table configuration or through the eBPF traffic redirect. And then as the request comes through the source Z-Tunnel, the source Z-Tunnel is going to make sure it has the keys and certificates of C1, so it makes sure it can represent C1 and establish the HTTPS connect tunnel. If there's no connect tunnel exists that can be reused, and then it's going to perform mutual TLS certificate exchange with the destination Z-Tunnel, and then the traffic will be forward to the actual destination. So it's very similar as the sidecar model. The key differences, though, is the Z-Tunnel manages multiple pods co-located on the node, and also it's using this new HTTPS connect tunnel to establish the connection. One thing I do want to talk about, you're probably wondering, right? You talk about layer 4 processing, right? What if I need a layer 7 processing, which is a key functionality of service mesh, right? So if I need reach layer 7 authorization policy, maybe based on a particular header, or maybe based on particular method, like a post or delete method. What if I need traffic resilience? What if I need traffic shifting? I need to canary roll out the new version of my proxy. In that case, how am I going to do this without a sidecar, right? So what we are introducing is a waypoint proxy that you can design, which is Envoy based, which is why you see the Envoy logo right there. So in waypoint proxy, you can use that waypoint proxy to continue to handle your layer 7 processing. And because, as I mentioned earlier, Envoy wasn't inherently designed to be multi-tenancy, so the waypoint proxy would be tenant scoped, right? So if your tenant scope is based on namespace, you can deploy a waypoint proxy per namespace. If your tenant scope is more based on service account, you would want to deploy a waypoint proxy based on your service account. So you do have the flexibility based on your business needs on that. So with Waypoint, these yellow orange-ish connection are also using the HTTP connect tunnel. So essentially when traffic sending from the source Z tunnel, it's going to have the knowledge knowing whether the destination has a waypoint. And if the destination do have a waypoint, it's going to send the traffic to the waypoint first. And then send the request to the destination Z tunnel. If the destination Z tunnel does receive the request, it will also always check whether the destination has a waypoint. If it does, it always also bounces the traffic back to the waypoint proxy. This is useful in case your source is not part of the ambient mesh. It always enforces the traffic goes through the waypoint proxy through the high-opinion process. All right, let's take a minute to talk through Edgebone. So essentially, this is the protocol we use to connect the nodes through zTunnel and also from zTunnel to the waypoint proxy. So you can think of Edgebone as a HTTP overlay. It's supposed to be transparent to developers, so something you don't need to worry about as developers. That's handled by the Service Mesh framework. It listens on the 15008 port. So it essentially would establish, the Z-tunnel would establish Edgebone tunnels per source and destination pair. So if there are existing tunnels it will try to reuse that existing connection between source and destination identity pair. If there's nothing existing, it will establish new connections. If you're interested to learn a little bit more about Edgebone, we do have a blog here. Feel free to check it out. But it's supposed to be more transparent to the average developers who develop applications. With that, I am going to jump into a demo, and hopefully Wi-Fi stays with me. The demo gods is with me. So I do have an environment. I have, which is a virtual machine in the cloud. I'm not exactly sure what type of cloud I use. By the way, is the font too small for folks in the back? Yes, is it better? All right. Let me know if I need to make it bigger or it's good. Bigger? All right. Better? One more? All right. Now I wish my laptop is bigger. I'm on a tiny laptop with 14 inches. All right, so what I'm doing right now is I'm actually deploying my kind cluster. How many of you use Kubernetes kind? All right, I do expect to be many of you. Thank you. So what I'm doing is, let me go through my demo environment. So essentially, I'm setting up a kind cluster with 4 nodes, and so that I can install Istio with Ambient on it, right? So that's after the kind cluster is set up, which will come up in a minute or two, then I would try to install Istio using Istio-Cado. By the way, there are 2 or 3 methods to install Istio. Istio-Cado is one way. Helm is another way you can use to install Istio. And when you install Istio, you can specify a profile. Because Ambient is relatively new in the community, so you do have to specify the profile equals Ambient. However, when Ambient is mature at Sidecar, when we start to recommend and feel confident about using Ambient in production, that's when we will move Ambient to the default installation profile. So you would no longer need that when that happens, which finger crossed we would expect to happen maybe later this year. All right, let's see if my environment is up. All right, so I have the kind cluster deployed, and I am just going to check the status of my pod. I think all the pods are ready because this command returned right away. And then the next thing we're going to do is we're going to download Istio. So download is just a simple curl command. Well, you know, we're just going to download Istio-Cado because the Istio-Cado contains everything you need to install Istio, including all the binaries for the images. So now we're going to install Istio, and remember we said profile equals ambient. And I'm also going to turn on access log in case anything goes wrong with my demo. We may need to troubleshooting. Hopefully that would not be needed. All right, so as this is installed Istio, we do expect to lay out the Z tunnel onto each of the 4 nodes. So the Z tunnel will be deployed as daemon set. Let's go back to our environment. Yeah, so we already got Z-tunnel installed. We got Istio-D, which is the control plane component we mentioned. We also got ingress gateway. Ingress gateway is the component used to control traffic into your cluster. We have Istio CNI installed. So the Istio CNI is the component that handles the traffic redirection between the Zero Trust tunnel to your application. So any incoming and outgoing request can always go through the Zero Trust tunnel first. And now our installation is complete. Very good. What we're going to do next is just view all the pods I was mentioning to you in the Istio system namespace, which is the default location for Istio installed. So these are the CNI nodes we mentioned, which is also deployed as a daemon set. These are the Zero Trust tunnel. As you can see, I have 4 nodes, so they are deployed onto each of the nodes. The other thing I want to install is Gateway API. How many of you are familiar with the Kubernetes Gateway API? All right, a few of you, right? So essentially the Gateway API is the new Ingress API that's incubated from the Kubernetes community. I believe it's already beta. They're targeting to be stable very soon. The Istio community is working with the Kubernetes community on the Gateway API because we're trying to standardize the Mesh API as part of the Gateway API. It's the Gamma initiative, if you haven't heard of it. The reason I'm deploying the gateway resources is because we need the gateway resource to deploy the waypoint proxy. All right, so the gateway resource is deployed. By the way, these are just customer resource definition. So it's not the actual resource, it's just the definition. So with that, we are going to deploy a couple of services for testing. So essentially, we're going to deploy a couple of fake service, which I'm using Nick Jackson's fake service. So we deploy web API recommendation, purchase history, and also we'll deploy a couple of Kerr client, which are the sleep pods and not sleep pods. So these are just pods to give us access to Kerr command so we can do testing inside of the cluster. So the flow goes to the client, which is sleep, calls web API, and web API calls recommendation, and recommendation calls purchase history. So let's go ahead and deploy the sample application. So I'm creating a test namespace, and I'm deploying all the sample application I was just mentioned to you, sleep, not sleep, purchase history, recommendation, and web API into that namespace. So notice right now, I don't have Sidecar at all, right? So let's go to the test namespace. I'm just deploying my application as usual as I'm outside of the service mesh, right? So what we're going to do next is we're going to test the sample application, just making sure it works, right? We haven't done anything with Istio. So from the sleep app, yes, it did get into the web API, and web API calls recommendation, which calls purchase history, right? So that's all good. And this is our setup without Istio. Now we're going to use one functionality of Istio, which exists in the Sidecar world today, is the ingress gateway, right? So through ingress gateway, you can expose your services to be accessed through outside of the cluster. So So what we're going to do is we're going to apply this YAML to expose Web API service. And if I go here, I can show you expose Web API service, what this YAML are. Essentially, it will deploy a gateway resource. And this gateway resource says, for this particular Web API gateway, I'm going to be listening on port 80 with HTTP, and my host is istio-explain.io. And my virtual service resource configs routes, right? When the traffic comes in on this particular host, istio-explain.io, please, on port 80, which is what's defined in the gateway resource, please route the traffic to the Web API service in the test namespace, and it's listening on 8080. So let's see if that works. The first thing we actually need to do is figure out the gateway IP. So the way to do that is actually go to the gateway service in my Kubernetes cluster and find out the load balancer IP. And with that, we should be able to run the curl command. All right, so now we are accessing the Web API through a host, an arbitrary host that we defined on the gateway resource. Now we're accessing it through the gateway IP, right? So this means I don't have to directly expose my Web API outside of my cluster. I might expose it through my Istio ingress gateway. So this is the basic function of Istio without any sidecar. So let's go ahead, move to start to kind of add in the paths to Ambient. As it's loading to the next demo, by the way, these are live demo. It's kind of a script in the environment to help me, to show you, but everything is live, as you can see. So, all right, so the next thing we're going to do is we need to kind of figure out how am I going to add these application Web API recommendation to Ambient, right? Because we want to kind of have mutual TLS. So I don't have to do mutual TLS inside of my application. So let's do that. Timing-wise, can somebody let me know how much time minutes I have? I'll try to be quick if it's short on time. Is it 10:54? Do I have it until 11:10, I believe, right? 11:10? All right, thank you. I appreciate that. Sorry. All right, so in order to add your application to Ambient, the only thing you need to do is actually label your namespace. So you label your namespace to say, hey, I need my namespace, everything in my namespace to be Ambient. Certainly, we have a little bit of intelligence. If you deploy your application with Sidecar in that namespace, we won't add it to Ambient because we know you have a Sidecar. But if your application doesn't have any Sidecar and your namespace has this label, we will enroll it as part of the Ambient. So let's click on that. So now, what does this mean for the Istio control plane, right? So essentially, we talk about the Istio CNI component. The Istio CNI components constantly monitors the pods and their namespace, whether it has this label. So when it's detecting the Web API, for instance, have its namespace have this label, it's going to start to set up traffic redirection. So all the requests coming or going out of the Web API pod, it would be redirect to the Zero Trust tunnel first. So if you do take a look at the Istio CNI logs, you will see Istio CNI is detecting that namespace test is enabled in Ambient. It's adding the pod recommendation, sleep, all these other pods into Ambient, and it's configuring the IP table redirection through the IP sets and routes, which are pretty complicated, so I'm not going to explain that. I don't think I know how to set up these detailed routes myself, but the idea is the Istio CNI handles all that automatically for you by detecting the fact that you want to the namespace to be part of Ambient. All right, so what's going to happen next with just this one single command is when the sleep calls web API, it's going to go through, the request is going to be captured by the zero trust tunnel, and the zero trust tunnel is going to try to establish the HTTP connect tunnel. It's going to be trying to do mutual TLS handshaking with the target destination Z tunnel, so it's very similar to the sidecar world. The key difference is though it's the per node proxy instead of a sidecar. All right, so let's generate some traffic, right? So in this case, we are going to call sleep to web API, and we're going to do a bunch of them. So you can see it's all 200, and we can look at the zTunnel logs to make sure, there's a bunch of traffic coming through zTunnel. So you can see zTunnel is going through the inbound and outbound request for these application requests from sleep to web API. All right, so what do you gain, right? We talk about mutual TLS. You have mutual TLS, which is very nice. The other thing you gain, though, is also you immediately gain layer 4 observability. By the way, just to quickly show you, I am still running my application. That was 7 minutes ago. There was no sidecar, and there was no restart, right? So I didn't need to restart anything to add my application to Ambient. Now let's take a look at layer 4 metrics. So what we're doing is we're going to find a node that web API runs, and we're going to get the paths of the zTunnel for that node web API runs, and then we're going to look at the metrics for instance, Istio TCP sent by total, which is one of the metrics, by the way. We collect like 4 metrics for layer 4. So sent by total is one of, I believe there's like connection reset and a bunch of other metrics. So with these metrics, you can actually see the sources principle and also the destination principle. So this shouldn't be surprise for you if you are familiar with Sidecar. It's essentially the specific identity format we use in Istio. The response flag, and some of these are empty because it's layer 4. By the way, this is important. This is how you know it's mutual TLS between the source and destination. So that if we have a dashboard, which I didn't install in your environment, you could install a Kayali dashboard, and then you will see the secure connection icon between the 2 services. All right, let's go ahead and apply layer 4 authorization policy, which is another benefit just to adding your pods to Ambient. So I'm going to go ahead and apply this layer 4 authorization policy to say, hey, I don't want to allow anything in the tester namespace, right? So the moment I add that, and now if I cur this command to use the gateway IP, so this means from my terminal, I'm calling the Istio ingress gateway, and the Istio ingress gateway calls the web API, which should be denied, right? Because of that policy. Yeah, you can see, we didn't allow that. All right, so let's figure out how to make it work. The way we're going to make it work is we're going to allow access from web API, from the sleep and also Istio ingress gateway service account to access web API. And we're also going to allow web API to access recommendation, and also recommendation to access purchase history. So let's go ahead and enable that, see if we can get this RBAC working. So go ahead and apply these 3 authorization policy. And now if I do call the call command, finger crossed it's going to work. Because I did set up the right RBAC policy. As you can see, it's working. Now, if I do call it from another pod, remember we had a not sleep pod, and I didn't grant layer 4 authorization policy for the not sleep pod. So that continued to fail. So essentially, by label your namespace, you have your pods in Ambient. You get mutual TLS, you get layer 4 authorization policy, you get layer 4 metrics without you needing to restart any of your application. So for those of you using Sidecar today, I hope you do agree this is kind of much better than Sidecar-less, right? All right, the next thing we're going to talk about is layer 7 authorization policies, because many of you probably feel, layer 4 authorization policy is not rich enough for my purpose if I want to tighten up the layer 4, the layer 7 authorization policy. In this example, we're going to go through a layer 7 authorization policy that only allow GET request. So if any request does not GET request, we're going to immediately decline that from sleep to web API. So in order to do that, the first thing we're going to do is deploy the waypoint proxy for the web API. Remember we talked about waypoint proxy is for layer 7 processing. So in this case, we do need a layer 7 processing. So we'll deploy the waypoint proxy for the web API service account, which I feel more confident with waypoint proxy per service account. All right, so the next thing we're going to do is we're going to apply this authorization policy to say, for this web API, I'm going to only allow the GET method, right? Nothing else should be allowed. All right. So now if I access from sleep to web API, I should be able to continue access. But if I'm sending not a GET, but a delete command here, then it's going to fail, hopefully. Yes, it didn't have anything, so because it's not allowing that to happen. Actually, I would expect a RBAC arrow. Looks like it didn't have the RBAC arrow. Let me make sure I apply this correctly. Yeah, so, right, it's here. Sorry, I missed it. It's right here. Okay, so it did deny the access, which is very good. Yeah, so so there are also layer 7 observability you can get, but just by deploy the waypoint proxy. In this case, look, we're getting the request protocol, we're getting response, we're getting the HTTP metrics from Istio. I do have more demo, but I want to pause for questions. So essentially through waypoint, you can also do fault injection, you can do traffic shifting. But I want to hear from you, see if you guys have any questions.